Which method did you use?
I think we ended up all the same.
All the same. So least common denominator is 2x minus 5 and x minus 5. So I'm multiplying it times each of the terms here. So from the top one, the 2x minus 5 is going to cancel, and my numerator would be x minus 5 times x minus 5. On the left, the 2x minus 5's cancel, and that would be x minus 5 times x minus 5. And on the right, the x minus 5's cancel. It's a minus in between, so it's minus x plus 2 and 2x minus 5. And then none of it canceled. Like in the front, you can't cancel the x minus 5's from the front because it does go into all three parts. So at this point, I would check my answers and see if it's there. And if not, I would FOIL it out. So the numerator is one of the special products. It's x squared minus 10x plus 25 over this one would be x squared minus 10x plus 25. And this one would be minus, I'm going to FOIL it out, 2x squared minus 5x plus 4x minus 10, or 2x squared minus x minus 10. And then I would distribute, so x squared minus 10x plus 25, the numerator stays the same. X squared minus 10x plus 25 minus 2x squared plus x plus 10. That negative changes the signs of everything after it. X squared minus 10x plus 25 over, combine my like terms here, negative x squared, negative 9x, positive 35. And then I would see if there were factors, like if I could factor the bottom factors of 35 that sum to 9. Again, you can also stop and check to make sure if that answer is there, then you know you're done. Madison.
We can't cancel out the x minus 5's because the ones in the bottom are part of the sum of the
Correct. Yep. Unless it was, if it was here and over here and here, now you can. But there is only on one part of the sum or difference in the bottom, so it can't be canceled. All right, so okay, 9. Again, 4 different fractions. So if it's easier to combine them in the top and then combine them in the bottom, keep, change, flip, you can do that. The other thing to do is look at all your denominators. So I've got 9, 4, 5, and x, and find your least common denominator. So what do 9, 4, and 5 all go into? So the easiest way to do it is do the multiples of the biggest one, right? So it'd be 9, then 18, then 27, and then you keep going. 36, 45, 54. What's next? 63. Until you get one that they all go into. 72, right? That's the one. Oh, 5 doesn't go into it. Just kidding. It's what? So don't stay here forever. 180. They're not going to be this big on your chest, but yeah.
What I did is like I times the times 36 in the bottom.
Times 36. So it doesn't go, that 5 doesn't go into 36, so you can't use the 36. In the top you can, like you can find the least common denominator here. That's 36. Find the least common denominator here, and then keep, change, flip at the end.
Yeah, that's what I did.
That's fine. That works. But you didn't get the right answer?
I did get the right answer.
You did or did not?
I did.
Oh.
I was so confused.
I mean, you want me to do it your method, but you got the right answer, so I don't know how I can do it that way. So if you did that way, then you're separating them out so that the top has a least common denominator. This would be times 4, and this would be times 4. It'd be 4x squared. This would be times 9. This would be times 9. 225. There's a minus between from this minus, and it's all over 36. And then you repeat it for the denominator. Now the least common factor, or least common denominator is 5x. So I'd have to multiply 5 and 5. I'd get 20. Multiply by x and x minus x squared over 5x. Then you have to keep, change, flip. So I keep the numerator, 4x squared minus 225 over 36. change it to multiplication, flip the bottom. And then this is difference of two squares, 2x plus 15 and 2x minus 15. That's not difference of two squares. So you literally have to multiply out what's left because they don't simplify. So instead of factoring it, they left it as 4x squared minus 225 over, and it would be 36 times 20 minus x squared. And I would see if that answer's there, because if it is, then you're done. If this is in factored form, so let's say it's 5x and then 2x plus 15 and 2x minus 15, then that could be written like that, but that would also, they would both be correct. And again, only one of them is going to be your answer choice. Yeah. Test. All right, so this is 10, okay? And again, with every one of these, you have two options. One is find the least common denominator of the whole thing, multiply it all out. The second is to separate them out, top and bottom, and then do keep, change, flip. So did you least common denominator of the whole thing? Yeah, okay. So the least common denominator of this whole thing, change my color, has a lot of parts to it this time. It's got a 3, it's got an x squared, and it's got an x plus 1. Each of those would be separate terms. So I've got, obviously the 3 is the only leading coefficient. There's an x, but then the x repeats raised to a higher power. So we have to take the 1 to the higher power. And then you've got the x plus 1 twice. So that's why that whole thing is your least common denominator. So when I multiply it out, I'm going to multiply it times each of the 4 fractions or 4 terms. From the first one, you would cancel out the 3, and I would cancel out 1 of the x's. And I end up with 4 times x plus 1. Then the plus comes from the sign in between. Then I go to the next one. From that one, the x squareds cancel. And I get 2 times 3 times x plus 1. So 6 times x plus 1. Then I go to the next one. The x plus 1s cancel. And I have 3x squared times x. So this goes over. 3x to the third. And then I go to the last one, and the x plus 1s cancel, and I get 4 times 3x squared, but there's a minus between. So minus 4 times 3x squared would be 12x squared. Now I distribute what's left. So 4x squared plus 4x plus 6x plus 6 all over 3x to the third minus 12x squared. Then I combine my like terms here. So 4x squared plus 10x plus 6 over 3x to the third minus 12x squared. Now, if this is multiple choice, I'm going to my choices and I'm seeing if that's there to save myself some time. If it's not, then I know I have to keep going and try to factor it. So from my numerator, I can actually take out a 2, and I'd get 2x squared plus 5x plus 3. And then 2 times 3 is 6. Factors of 6 that sum to 5 would be 2 and 3. I'd replace that middle term with 2x and 3x. And then I factor by grouping. So the 2's on the front. 2x comes out here. God bless you. I get x plus 1. 3 comes out. I get x plus 1. And then I still have the 2 on the front, the x plus 1, and the 2x plus 3. So that whole thing is my numerator. In the denominator, I can take out a 3x squared, and I get x minus 4. None of it cancels, so this stays as your answer. If it was open-ended, both would have been fine because it didn't simplify. But again, I would make sure I use like the multiple choice part of this to my advantage and see before I even factor it is that one of my answers? And if it is, then you know you're done, okay? It's not like it's gonna be tricky where the answer before it's factored and then the answer after it's factored is gonna be here. For like, obviously factor completely if that was like multiple choice, which it's not. If it was multiple choice, that might be, but not for the complex one. Valerie?
Over 9.
Yeah, any other questions on 10 before I move it? Yeah.
So the multiple choice will only be one or the other.
Correct.
Okay.
Yep, yeah.
Where do you get the 2 in the last answer? When it's 2.
I took the 2 out of this step here
And then you.
and then factored it again,
Where you find the
first and last.
How
Yep.
many questions were these over here? How about
1.
one?
Mm-hmm.
One question on the 10.
From complex fractions. Yep,
How many questions are there?
16. 1.
That's not.
Is it gonna be an easy one or is it gonna be really complex?
It's somewhere in between.
Wait, what do you mean? Like, there's only one that's not.
1 complex fraction.
Oh.
Yeah.
Only one of these.
So this is all the concepts that you need to know. The review, the PDF that is on Canvas has all of it, okay? It goes back to the P2 stuff, into the factoring completely, into the stuff from P5,
The test is tomorrow.
Thursday. Okay, this first one, you have to factor, well, in all of the adding and subtracting, you have to factor the denominators. So on the first one, it is already factored. There's nothing else there. But on the second one, this would be x plus 2 times x plus 2, which you could leave like that, or you can rewrite it as x plus 2 squared. Now when I find my least common denominator, it is the combination of those two, right? So x plus 2 is there from the first one, and then it is repeated in the second one, but to a higher exponent, which means that exponent, the higher exponent, is my least common denominator. So then on the left, I have to multiply this by what's missing from the denominator. So from here to there, I'm missing my other x plus 2. That's a special product, so you can use your shortcut if you want to FOIL it out, or you can FOIL it out. The shortcut is, because those are opposites, square the first one, square the second one, put a minus between them. If you don't remember your shortcut, then you have to FOIL it out. Then there's a plus from the middle. The second one already has the full denominator, so I don't change it. It all goes over my least common denominator. And then I combine my like terms, and I get x squared plus x minus 6 over x plus 2 squared. And then I see if I can factor that. Are there factors of negative 6 that sum to positive 1? Yep, they would be. Nope. Plus 3 minus 2. Does any of that cancel? No, I can't cancel a negative 2 with a plus 2. That's my answer.
The answer above it wouldn't be right.
The answer, if it is a multiple choice question, the answer above it might be there because it's not factorable, because it's not simplifiable. So you just have to know, if it was open-ended, I'd take either of them. If it's multiple choice, you're looking for one or the other.
Can you go back on this?
Yeah.
You could have also written like the x squared plus x minus 6 over x squared plus 4x plus
Right, so if it's open-ended, I would take either of those. If it's multiple choice, only one of them is going to be there. Yeah, you're welcome. For the second one, again, start by factoring your denominator. So on the first one, I would take out an x. And then I would get x. Okay, this was the second one. So we factored the denominator. I took out an x in the first one. And I got x times x plus 6. And then the x plus 6 was already there. My least common denominator is x times x plus 6. The first one is missing nothing, so it just gets brought down. The second one is missing the x, so we multiply it by x here. The minus comes from in between, and then I took that x and distributed it. I got here 15x plus 2 minus x squared minus x. Combine my like terms, and I ended up with negative x squared plus 14x plus 2 over x times x plus 6. If you try to factor the numerator, there are no factors of that negative 2 that are going to sum to 14, so my answer is going to stay just like that. All right, so for that, what is this, the third one? This would be 9 minus x and 9 plus x. So the order is different than you're used to, and it has to stay that way. Or you have to take out a negative 1, and that gets messy. So your least common denominator is 9 minus x, and 9 plus x or x plus 9. It doesn't matter the order on the sum, okay? But you have to have the negative has, or the subtraction has to go in that order. So the first one is not missing anything. It's going to be kept as 6x minus 1. Then the plus comes from in between. The second one has the plus, it's missing the minus. So it's going to be 2x times 9 minus x all over that denominator. Then I'd get 6x minus 1 plus 18x minus 2x squared over, again, that denominator. And then I get negative 2x squared plus 24x minus 1 over that whole thing. 9 minus x and 9 plus x. There are no factors of 2 that sum to 24, so it's going to stay just like that. A little bit better, okay? Obviously still need some work, but a little bit better. The last one, the bottom factors, x plus 1 and x minus 1. I'm just going to finish it real fast. Least common denominator is x minus 1, x plus 2, and then x minus or plus 1. So the first fraction is missing the x plus 2 and the x plus 1. The second fraction is missing the x minus 1 and the x plus 1. And the denominator is missing the x plus 2. All the other stuff cancel out. So for the first one, I'm going to get x plus 2, x plus 1, and x plus 1 again. Minus comes from here. Then it's x minus 1 times x minus 1 times x plus 1. All over 15x plus 3 times x plus 2. So now I'm going to FOIL these out individually off to the side just so we can see it a little bit clearer. So this is a special product, x plus 1 times x plus 1. So I'm going to keep the x plus 2. But the x plus 1 times x plus 1 would be x squared plus 2x plus 1. And then I FOIL this, x to the third plus 2x squared plus x, 2x squared, 4x, 2. So I get x to the third plus 4x squared plus 5x plus 2. Now it's going to take the place of that one. Then the one on the right, this is a special product. Well, they're both special products, but if you use this one, it's going to cancel, so it makes it a little bit easier. I'd get x minus 1 times, those are opposites, so x squared minus 1, because you square the first, square the last, and put the minus between them, and then FOIL this out. So this would be x to the third minus x squared plus 1. And that's going to take the place of this whole thing. Now there's a minus here, so I'm going to keep it there to remind myself to distribute. I'm just reordering it. To distribute that negative. So my numerator I'm going to rewrite again through x to the third plus 4x squared plus 5x plus 2 minus x to the third plus x squared plus x minus 1. That's the numerator. The x to the thirds are going to cancel. 4x squared and x squared would be 5x squared. 5x and x are 6x. And positive 2 and negative 1 would be positive 1. That's my numerator. Now the denominator, I have to FOIL out. So you can actually take a 3 out of there. And I would do that first to see if I can cancel anything out. My numerator, see if it factors. 5 times 1 is 5. Factors of 5 that sum to 6 would be 1 and 5. So then I get 5x squared plus x plus 5x plus 1, and I factor by grouping. Take out an x, 5x plus 1, and there's already a 5x plus 1. So my numerator is 5x plus 1 over, or times, sorry, x plus 1, all over what I got from here. 3 times 5x plus 1 times x plus 2. And then the 5x plus 1's cancel, and I get x plus 1 over 3 times x plus 2. So I would say good news on that is the one on the test is a little bit less complex than that, but that is still the process of complex numbers. So your goal for this evening is to complete this review for your test. It's going to take you through P2, it's going to take you through P3, P4, and P5. You can actually skip 5. That continues on to that page and then resume again at 8. This is your special products, and then we're back to adding and subtracting complex numbers and rationalizing.